Now, we are going to apply the concept in a real in a simulated situation here, where again we are using TV and Ensemble. As you can tell from this simulation, that we have two species, the blue species and the green species, and they have different mass as well. So, we have control on the mass of the blue particles, and we can change that, and you can see the green particles are already there. There are 200 particles total. Number of green particles is 90, and that is a solid surface. And then if you think about, this is an argon which is in the solid surface, and this is a liquid, another liquid, let us say krypton, with a different Lennard-Jones parameter, 110 atoms. And you can see that this is liquid and gas phase together. There are some particles flying off. This is a very pliable system. So, you are looking at wetting of the liquid layer on the solid surface of argon. And again we have the same kind of different situation. We will start with the heat bath first to see what kind of property calculations we can do here. So, let us put the properties up. Now, you can see all the properties: time, temperature, kinetic energy of green particle, kinetic energy of blue particle. Then you have potential energy, number density, volume and pressure. Now, let us do real units. So, you can see that also in terms of real units, time is in second, temperature in Kelvin, kinetic energy joules, potential energy joules, and number density in meter cube, and volume meter cube, and pressure in Pascal. Now, let us start it. Now, we will let it go for a little while. So, let us look at the kinetic energy term, and you can see the green line and the blue lines. Let me stop it. So, you can see the green line is fluctuating differently than the blue line, because green is in solid state and the blue line is in the liquid phase. We are looking at the kinetic energy of the two systems, but as you see from its phase, it is now spreading over the surface, and that is called wetting. You can see that these globules, and if you look at temperature, it is very low, and you can see that this is creating quite a bit of almost like droplet. So, you are seeing that droplet formation because of the surface tension that is coming out of the green balls here. So, initially it was like a layer, but because of the surface tension, you can see that it is creating a droplet. So, now we are getting to the droplet, where you can see a droplet of the liquid layer, but it is not spreading because of the surface tension. And so, there are certain different ways we can change the shape of this globule. So, now let us look at the droplet with a different mass if we change the mass. Before we go to that, let us look at some of the other parameters. You have number density 4.49, volume, pressure, they are all stabilized. So, let us look at some of the terms. Energy versus time, that looks good. If you look at volume versus time, that is constant. Let us look at this a little bit. Yeah, it is a constant because it is TVN. Velocity distribution, let us look at that. So, you are seeing the velocity distribution is much more peaked for the blue, and the green we are looking here. Let us stop that, and let us change the particle mass, and we are changing the blue particle mass. Let's see what is the effect of wetting. So, right now they are forming almost not a layer, but they were forming a droplet. Now, with the higher mass, you can see that they are settling down, and you will see that they are spreading a little bit more because of the mass now is acting on the system. So, there is more wetting with the mass being increased of this particular system. Now, let us look at here. Temperature is constant. This is where the bath is, and so this is the, if you let us say it is a Nose-Hoover bath, we are adding, subtracting energy here. Now, let us see if I close the bath. Now, you can see immediately temperature is fluctuating and it may even drift. Let us focus on the temperature here. Now, you can see that it is differing, but fluctuation is happening here, but temperature is still very low. So, you are not seeing that effect, but because of the we have already changed the parameters here, that it is heat bath is not constant. So, because of the fluctuation of temperature, you can see more wetting happening. So, for us to keep this whole situation in control, we have to have heat bath. So, let us put the heat bath on, but now we are going to change the boundary condition to no wall. Now, you can see that this mass can go out of that and appear from the other side, and it is more likely in this case the bulk behavior, because there are no reflecting wall, no confinement. You can see the wetting happening, and this whole blue system is spread over the entire system of the green surface that you are looking at. Now, we can also create a lot of change in the system if we change temperature a little bit, and that will rescale temperature for both the blue system and the green system. So, let us look at that. We are still, the heat bath is on, which means we are recalculating the temperature, rescaling the velocities. So, let us stop it here, and then I will change very little temperature. Start that. So, now you can see that the particles both sides are now feeling the rescaling of velocity, they are moving up and down. There is also some breakage and formation of the grains in the green part, and for that to happen, it is important that we are keeping the temperature constant, which is where we are. And if I increase the temperature further up, then you will see breaking of the surface, because this surface is equilibrated very loosely. So, now you can see that the surface is broken and surface itself is melted, the other particles are also melted, and now you can see the gaseous phase on one of the particles, which may be lighter particles, and then now you are seeing that the formation of droplet from the surface that was the green surface. So, now let us do one more thing, and we are increasing the weight of the blue particles and see what happens. I am going to increase the blue particle mass quite a bit. Now, you see that there are two particles, there are diffusion happening between the two different species, but now you can also see that the blue particles are coming down to the bottom surface. So, in this case gravity is on. So, there are some gravitational effect because of the mass. So, now you can see that the blue particles are moving this green particles up. So, now you may see a reverse wetting of the blue surfaces by increasing its into the green surface. So, now green does not have surface anymore, it is almost breaking down. So, now with this situation, let me increase the mass of the blue quite a bit, all the way up, and then reduce the temperature, because we want to see what will happen to the blue particle deposition, and we can only do because of the temperature rescaling here. So, now I am going to stop that, and let us reduce the temperature all the way to 0.01. And now, if you look at here, we will see that the blue particles are forming a surface, they are coming down, they are much heavier than now heavier than the green particle. With this situation, now we are able to create different situation of the wetting process. So, this is a good example that temperature rescaling, which is connected with the mass, we are able to change the behavior of the wetting of the green surface. We generated now blue surface by increasing their mass, and now the blue particle is forming a droplet on top of the blue surface, which is down here. And so, this reversal was we were able to understand because of the TVN ensemble, temperature constant, volume constant, and the number of particle constant. And we can also look at some other situations. So, I will encourage you to go and look at this particular simulation, which is called wetting, and you can now understand two different species variable and understand how we can use this situation to understand TV and ensemble. Thank you.